Hi, so this is my final summary of learning video for teaching science. So here we go. So in the case of science, a misconception refers to an incorrect view or opinion, and it's not based on any scientific fact or principle. And in many cases, these misconceptions in science are due to flawed thinking or just a simple misunderstanding, and sometimes people do have trouble letting go of these misconceptions once they're confronted with conflicting information. So during practicum, there were a few experiences I had that really did show me good examples of what these misconceptions are. The first misconception I remember seeing was when I conducted an interview with a student about beach sand. As I was asked to ask the student where beach sand comes from, he told me that sand comes from parrotfish because they live in the coral reef and break down the coral reef into sand particles. And at first I was really confused by this answer, but I Googled it and find out he was partially right. So even though parrotfish, they do break down parts of the coral reef into sand particles, they're not nearly responsible for all the sand in the ocean. But after researching this and looking over his response again, I kind of did understand how this misconception formed and how he was trying to apply this fact he had about parrotfish into this overarching explanation. And then another misconception I heard was from an interview that one of my other classmates did with a student. And she told me that in this interview, she had to ask a student what mountains were made out of. And in response to this question, the student told my classmate that the mountains were made out of ice and snow. But this kind of made sense to me because considering all of the images of mountains, snow, and ice, I could, people skiing on top of them, I could see how the student maybe formed this misconception and see kind of what led to it. And I think that understanding students' misconceptions is critical in effectively teaching many topics within science. In my future classroom, this is something that I definitely plan to do. A way that I'd leverage these misconceptions is, for instance, before conducting a lesson over any given topic, I might have students participate in some type of activity that will reveal what their potential misconceptions have towards the lesson or topic. Almost kind of like a pre-assessment, and then I can use the feedback I get from my student to make adjustments to my lesson plan in order to better address what their misconceptions are and show them what the correct information is. So in terms of progression of standards in NGSS, this refers to standards that build upon each other. So as a certain set of standards may be based off of one disciplinary core idea, it will start off as more basic in the younger grade levels and then become more complex in the upper grade levels. So as learning is seen as a developmental process, these progression of standards allow students to grow along with these standards in science. For example, I recently did a 5th grade lesson plan about the distribution of fresh water on Earth. And when I was looking back, I saw that in grades K through 2, for this topic, students would mainly focus on where water is found on Earth. And then in grades 3 through 5, they would learn that most of Earth's water is in the ocean, but much of Earth's fresh water is in glaciers or underground. And then in grades 6 through 8, they would learn about water cycles among land, ocean, atmosphere, and how it's propelled by sunlight and gravity. So basically you can see that with each disciplinary core idea within NGSS, it's gradually expanded upon throughout the grade levels from basic to more complex, and ultimately this allows students to gradually expand their knowledge of any given topic within science. So if I was a 5th grade teacher teaching the Performance Standard 5 PS1-3, so I looked this up, and this standard says that students will make observations and measurements to identify materials based on their properties. So doing a little research on the disciplinary core idea this follows, I discovered that in grades K through 2, students learn that matter exists as different substances that have observable different properties. Different properties are suited to different purposes. Objects can be built up from smaller parts. and they learn this through the standard 2 PS1-1. So as students already have learned about observable properties of different materials, there are a number of things that I would need to do as a 5th grade teacher teaching the standard. I would basically need to teach students about measurements, how to measure these properties, more specifically measurements of a variety of properties that can be used to identify materials. So as you can see in the younger grades, students already know how to observe these properties, so I would just have to teach students how to measure them in order to identify whatever material they're interacting with. For example, I would have students observe the color, hardness, reflectivity, electrical conductivity, and many more things of different rocks and minerals in order to discover what they were based off of these properties and measuring these. And learning this would ultimately lead students into standards that are expanded on in grades 6 through 8, where they consider the fact that matter is composed of atoms and molecules and can be used to explain the properties of substances, diversity of materials, states of matter, phase changes, and conservation of matter. So you can see here how the standards, differ. Back in K through 2, it's more simple. 5th grade, kind of intermediate, then, you get to 6 through 8, and the concepts get a little more complex, but you definitely can see how they build upon each other and how, what, as a 5th grade teacher, I would need to teach them the skills that would lead them in to building these skills later on. So for the 5E learning cycle, there are a total of 5 stages. So the first stage is engage. So during this stage, students' interests are piqued as their prior knowledge is activated, and they're asked thought-provoking questions by the teacher. So in order to do this, a teacher might show students a short video or introduce them to a situation or phenomenon that may challenge their thinking and ask them really thought-provoking questions on this. And the ultimate goal of this phase is to just, pique their interest and get them interested in what they're about to learn through the activity. So the next phase is the explore phase, and during this phase, students get the opportunity to conduct hands-on investigations and experiments with little guidance from the teacher. So as many refer to this stage as an opportunity for failure, students are supposed to struggle as they attempt to make sense out of the materials or information that they're working with. So for example, I planned in an explore activity where students needed to mine with toothpicks all the chocolate chips out of a cookie without moving or breaking the cookie. And I didn't tell them what they were doing this for or how to do it. And as it proved to be difficult for the students, this ultimately kind of helped lead into a lesson plan about the effects of mining on Earth's surface. So I thought that was a good example. The next phase is the explain phase. And during this phase, students get the opportunity to build their knowledge about the topic as the teacher introduces vocabulary and explanations for the concept of the lesson. And in doing so, students can refer to the data and information that they collected during the explore activity in order to generate explanations with the new information that they have learned to kind of summarize what they learned through the last activity. And in order to do this, the teacher would ask students higher level questions about the activity and content in order to help them draw out these explanations. So the next phase is the elaborate phase. And in the elaborate phase, students apply and transfer this newly learned scientific concept and process skills to real-world applications or problems. So this phase is different from the explore phase because this activity is supposed to connect to their lives, and they're going to be using all the content that they learned during the explain phase. So for example, in a lesson plan over the water cycle, the teacher may have students apply the knowledge that they gained during the explain phase and create projects about how they can conserve water within everyday life. So that would be an example of that. And then the evaluate phase is simply, during this phase, the teacher evaluates what the students have learned through the use of some sort of assessment. This could be summative, formative. Many teachers may use worksheets, exit slips, or rubrics in order to determine the level of mastery. In my science unit teaching plan, I made like a little Kahoot and rubrics for the project, so that is a way that teachers would evaluate it. So for the engineering design process, it's similar to the 5E but has some differences. There are a total of 5 stages. The first stage is ask, where students are introduced to a problem and they must ask questions in order to determine what the problem is. Next, it is the imagine. This is where students get the opportunity to imagine or come up with possible solutions to this problem and choose the best idea or option. Following the imagine, there is plan. This is where students get to come up with a plan of how they plan to design their solution or design. So in doing so, they'll make a list or of materials they might need, or draw a diagram of how they plan to create their design. Essentially, it's in the name, it's all about planning. The next is the create stage, and during this stage, students will have gathered their materials and begin to construct and build their designs. And once they build their designs, they'll test it out to see how it works. And lastly, there is the improve stage. And after testing their designs, students will think of ways to improve or make it better. Once students have made these improvements, they can test out their design again, and the process could continue all over again if they want. So in many ways, deep learning occurs in each stage, but the imagine and improve stage involve deeper critical thinking, in my opinion. Through the imagine stage, students must consider multiple different ideas and narrow them down into the design that they believe will be the most successful. And on the other hand, during the improvement stage, students must observe the results or effectiveness of their initial design and determine what improvements can be made in order to improve their design. And overall, these 2 stages invoke deeper thinking and problem solving, because they must use creative and critical thinking in order to come up with solutions for a given problem. So throughout this semester, I pretty much liked every single assignment that we had to do. And surprisingly, I really did like doing the science unit plan. And even though it was a lot of work, it took a lot of effort, I feel like I really learned a lot, especially by creating the 3 separate lesson plans. For my science unit, I saw myself improve through each lesson plan that I made, and I felt like by the last one, it was like the best lesson plan I've made throughout this class. And I also enjoyed how creative I got to be while making my parent newsletter and foldable, so I thought that was really fun. An assignment that I particularly didn't find useful was the student misconception interview. And this was only because I only got to interview about 2 students, so I didn't really get a clear understanding of the misconceptions that maybe a majority of students in the class held. But other than that, I could see the purpose of why we had to do that. I just wish I would have had the opportunity to learn a little bit more about all the students in the class. But overall, I absolutely love this class. Before going into it, I wasn't sure about my abilities to teach science, but that all changed after having taken this class. Now I see that teaching science can be really fun and creative, and you can come up with really engaging activities and lesson plans for students to truly learn and soak up all of the content. So that is all I have for you. Thank you so much for listening, and have a good summer.